Air is the fuel for speech, so I wanted to talk to you a little bit about the mechanism of breathing, and I have a model. Here's my model, and right away you can see there's this sort of jar, and you can see two balloons inside that represent the lungs. There is a hole here, which I guess would be sort of the glottis leading to a plastic tube, which would be the trachea. And there's a membrane down below, and this would serve as the diaphragm, okay? This jar is sort of the rib cage, and inside would be the thoracic cavity, okay? Now, the key things to realize, this area inside this jar is closed. There's no opening to the outside air. This opening goes into the plastic tube and is closed off by the lungs, or the balloons. So this part is open to the balloons, but this part inside does not connect to the outside air. That's important. So when we take a breath, the diaphragm will contract, and when it contracts, it lowers. This creates more room inside this closed space. And so as it creates more room, it's going to make negative pressure, okay? And so by making negative pressure, it actually pulls the balloons to expand, okay? And the balloons can expand because they're connected to the outside air. And so as the negative pressure pulls on the balloons, they expand, sucking in air here, letting them inflate, okay? So for regular tidal breathing, we have sort of a relatively even breathing in and breathing out. As the diaphragm relaxes, it goes up, which creates less space inside, which creates positive pressure, which pushes the lungs and pushes the air out through the trachea and out of, I guess, the glottis and wherever the mouth would be up here. All right. So a couple things to be aware of. One of the things your book talks about is how the rib cage expands to get out of the way of the lungs. And that's true, because if you watch my model, the lungs only inflate till it hits the sides. There's no more room, and so they can't inflate anymore. But that's not the whole story. The rib cage expands, and that expansion also creates more room. And that also creates more negative pressure, which helps the lungs to expand and pull air in. Okay, so it's not just about moving out of the way of the lungs, although it does have to do that too. All right, now when we breathe for speech, it's different than tidal breathing. The inhalation is much quicker and deeper, and then the exhalation is very slow. It's regulated. We sort of valve the air and let it out slowly. And we do that because if I don't do that, and I start talking to you, if I don't hold the air and let it out slowly, I'll just run out of breath, okay? And I won't be able to talk for a longer period of time, okay? And so it's all these changes in pressure that make this happen. That's why if someone gets a puncture in their lung can't inflate because it can't expand. The negative pressure won't open it because the inside of the thoracic cavity will be connected to the outside air. All right, so let me show you what that might look like. So if I open this internal space, those lungs will never ever inflate because the air pressure can equalize, okay? And so it won't try to equalize by expanding the lungs. So we have to have a closed system. Oh, I've got to make my diaphragm relax, and then we can inflate. So I hope this clarifies. So negative pressure is what's making the lungs inflate. Positive pressure is what's making them contract. We don't control our lungs directly. It's something that happens through a process of changes in pressure. Hope this helps.